Hi, this is Tony Northrup for Train Signal's SSCP Certification Video Training course. And in this lesson, I'd like to talk to you about firewalls and proxies, two of the most important security elements of a network. As you might recall from previous lessons, firewalls monitor network traffic and drop any traffic that they don't think is safe. Anything that hasn't been explicitly allowed through the firewall is dropped by a firewall. Now, there are two types of firewalls, network firewalls and host-based firewalls. As you can see here, the network firewall connects to the network. It exists on the network between the host machines and the internet or whatever it is you're trying to protect. All communications between the two networks go through the firewall. This computer wants to access trainsignal.com. Those requests get passed through the firewall, and the firewall gets to decide if they continue on or not. So an administrator could block trainsignal.com. I don't know why they'd want to do that, but more likely the network administrator will configure the firewall to block requests coming in from the internet and only allow those requests that are specifically required for the applications used on the internal network. Now, the host-based firewall here is actually a chunk of software that's running on this PC. That allows the host-based firewall to monitor all communications coming in across that PC's network adapter. So now I'd like to talk about the pros and cons of both host-based firewalls and network firewalls. First, the host-based firewalls. The pro is that, well, it's software-based, and they've built that feature into every modern operating system. That includes tiny operating systems like the one running on your smartphone, as well as Windows and Linux and Google Chrome OS. Everything you can think of has a host-based firewall nowadays. It wasn't always like that. Windows XP, believe it or not, didn't really have a host-based firewall built into it, nor did earlier versions of Windows. They just accepted every single request that came in. And as you can imagine, they were really susceptible to many different types of attacks. One big advantage of the host-based firewall is it goes with the host. Because it's running on the host, you can pick it up and connect to the Wi-Fi network at your hotel or a wireless 4G network, and that firewall is still active. As opposed to network-based firewalls, which are physically connected to a couple of different networks and won't protect you when you travel off the network. Host-based firewalls, because they're running as software, they can investigate any part of a packet coming in. If you fire up a VPN and you're tunneling your communications through a network firewall, the network firewall can't inspect a single packet. It just lets everything through. Host-based firewalls aren't susceptible to that. They can inspect the contents of a data even if you're running a VPN. Host-based firewalls also have a lot more insight into the computer, so you can set up firewall rules for specific apps. You can allow all traffic from Microsoft Word if you want to, no matter which port it's going to be on. If you have web server software running on a server, you can allow that web server through the firewall. And then if an administrator configures port 80, well, port 80 will automatically be allowed through the firewall. If an administrator configures port 8080 or some other random port, you don't have to separately go into the firewall and configure those ports. The host-based firewall software can say, whatever connections this particular app wants to listen for, I'm okay with it. Just let it all through. It really simplifies configuration, and it also reduces security risks because that same firewall will allow connections on port 80 for your legit web server software, but won't allow port 80 connections for malware or something that you haven't approved. As I mentioned, all modern operating systems have host-based firewalls, but older operating systems don't. So with those operating systems, you simply have no choice except to deploy a network firewall. Host-based firewalls can also be turned off. And believe it or not, this happens a lot, especially when host-based firewalls were new. They were causing a lot of problems. There were apps that simply wouldn't work with a host-based firewall because they didn't know to send a special message to the firewall saying, hey, I need to use port 139. So they simply wouldn't work. And you know how administrators would troubleshoot this? Well, they'd start by thinking, this might be a firewall problem. Just to test it, I'm going to turn the firewall off. And then this always happens because people are lazy. Once you get things working, you're done troubleshooting, right? Now, what the administrator should do is turn the firewall off, determine that it is indeed a firewall problem because it now suddenly works, then turn the firewall back on and figure out precisely how to configure the firewall to allow the app to work. But more often than not, the administrator got it working with the firewall turned off and just thought, back to the user it goes, ticket closed, and then the host-based firewall just stays off, and the computer loses all its protection. That still happens today. There are computers that have host-based firewall software turned off, and they're just susceptible to a massive number of attacks. It just creates a very large attack surface. Host-based firewalls can also be misconfigured by users. Modern software pretty much handles this automatically, but if you do require a user to change a firewall, or if there's some app not working and the user thinks it's part of the firewall, they might go in there and open up a bunch of ports or approve a bunch of apps, in which case the host-based firewall gets bypassed anyway. And if an app can run with system privileges, if it can modify settings, then it can change your firewall. So just like Word could configure your firewall to automatically allow some incoming connections, well, guess what? Malware can do that too, provided that you approve it and allow it to run. Host-based firewalls are part of the operating system generally, and as a result, they're vulnerable to bugs, just like any other piece of software. And there certainly have been vulnerabilities in the past related to different firewall apps that would allow traffic through or allow somebody to exploit the computer specifically because of the firewall. Of course, this always happens. There'll be an update that'll fix it, but it's a risk you should be aware of. Host-based firewalls tend to be more complex than network-based firewalls, so in theory, the greater the complexity, the greater the potential for vulnerabilities. Now I'd like to talk about some common features of host-based firewalls. The first is URL filtering. Host-based firewalls can monitor the websites that you visit and decide to allow them or block them. Now, in a home environment, you might use this to allow your kids to visit only the websites that you approve, or to block them from websites that you know are bad. The Family Safety tool in recent versions of Windows allows you to do that. In enterprise environments, well, you can use it to improve productivity. You can simply stop people from going to Facebook or Reddit, and God knows how many hours a day that's going to save you, right? But besides just blocking websites based on their content, you can also use it to block websites that are potentially malicious. Tools like Internet Explorer, Smart Screen Filter, and McAfee Site Advisor block sites that they know are bad. Microsoft and McAfee maintain long lists of sites that are known to host malware or to be phishing sites, and when you go to visit a site, well, they'll check the URL, and if it's on that list, it'll warn you. It might still let you go there, but it'll warn you and say this might be bad. So there, you're not deliberately going to look at any bad content, but it's kind of watching out for you. That's a powerful feature of host-based firewall software. Host-based firewall software can also scan the contents of packets and the data being written to the disk and look for either algorithm-based heuristics or specific signatures, sequences of data that indicate something bad. So this could happen when you were downloading a file. The host-based firewall would have a couple of opportunities. It could look at the network traffic and see, oh, you're downloading malware.exe. I need to stop this process. The host-based firewall software could also monitor the data that you're writing to the disk and see that a particular sequence of 20 characters exists only in the header of malware software. Stop the data from writing to the disk and tell you, hey, something's going wrong. You need to look at this. These are all things that network firewalls aren't great at. Network firewalls certainly can't inspect the data being written to your disk, but they often can't inspect the network data either if it's protected by HTTPS or a VPN or IPsec or something else that encrypts the data. In the Microsoft world, there are a couple of other tools that provide these capabilities: Internet Explorer Content Advisor and Microsoft Security Essentials. You'll notice I'm throwing out a bunch of different names, and there's also a tool called Windows Firewall and Windows Advanced Firewall. So why all these different tools? Why don't they pull it all under one name? I don't know. But they're all host-based firewall features, and I consider them all to be part of the operating system's firewall capabilities. Now let's talk about network firewalls and the things that are good and bad about them. On the upside, a network firewall protects all the hosts on a network. Regardless of whether it's your iPhone or your Windows 98 computer, the network firewall has got your back. It's inspecting every packet that travels through it, comparing it to a long list of rules, and dropping everything that doesn't match an approved rule. Bad stuff can still get through, though, as I discussed earlier. Network firewalls also provide centralized configuration and management. There's no one tool that will configure the firewall on your Windows 8 computer and on iPhones that are connected to your network. That's just not available. You can use things like Active Directory group policy to configure all the computers running Windows in your organization, but it's not going to apply to the Linux-based computers or your Android phones or other devices. So, however, your network firewall is configured in one place, probably because there's just the one device. That makes things much easier. Network firewalls also can't be messed up by users, and because you probably have some access control associated with it, it'll be harder for your network administrators to mess up. They probably take it a little more seriously than they would when they were just troubleshooting a problem with an app on somebody's computer. On the downside, they get completely bypassed by VPNs, and VPNs and other types of tunneling have become so common nowadays that network firewalls are becoming less and less useful every day. Nowadays, everything is tunneled through HTTPS, and the network firewall can't inspect the packets or do anything about it. So host-based firewalls become increasingly more important. Network firewalls also can't authenticate apps. They can look at the port number and see, oh, this is coming on TCP port 80, so it's probably web communications. But they don't know if it's coming from Google Chrome or Internet Explorer or Apple Safari. So they can't authenticate a specific app. And it could be some piece of malware that's using port 80. The host-based firewall can determine the process and executable that's associated with any given piece of network traffic, giving it more powerful authentication capabilities. And finally, if something goes wrong with your network firewall, well, it exposes every host on your network. It could be thousands of different hosts. So if an administrator does go in and turn it off or set up some forwarding rule that shouldn't exist, the consequences could be really major. What that means is you really need both network firewalls and host-based firewalls, and I wouldn't even go so far as to call it belt and suspenders. It's really just one long belt. Now I'm going to go over 3 different firewall-related terms. This doesn't come up so much in the modern era, but it did 10, 15 years ago, and they mentioned them on the SSCP objectives. So I want you to know terms like packet filtering firewalls and the next couple of terms that I'm going to introduce. Packet filtering firewalls are also known as stateful firewalls, and it describes pretty much every firewall, whether host-based or network-based today, but it didn't always. It used to be a cool feature that you kind of had to pay extra for. Packet filtering firewalls filter packets based on the information in the header of each different packet. So they can look at the source and destination IP address, the source and destination port number, things like the IP protocol number. When we describe it as a stateful firewall, that means it's remembering the state of every incoming and outgoing connection. So if 10 users are connecting to different websites, well, the stateful firewall remembers those 10 connections and only allows the responses back from those websites to return back to the original host. So it has to keep a big chunk of memory that memorizes every incoming and outgoing connection so it can associate newly received packets with one of those connections and use that to allow those packets through when they would otherwise be dropped if they hadn't been previously solicited. So that's a state. And you know how much memory this takes? It probably takes like 16K. So it doesn't take much. But back in the day, that was kind of an expensive proposition, right? So not all firewalls were stateful back in, say, the 90s. But nowadays, every firewall keeps track of state, so it's kind of a given. Packet filtering firewalls, though, don't, by definition, look at the packet contents. They just look at the header and make decisions. So they don't know if you're doing an HTTP GET request for malware.exe. They have no idea. They only know the source and destination IP address and the source and destination port number. They might be able to tell that it's probably an HTTP request, but they don't know what you're requesting. Packet filtering firewalls are good because they're fast and cheap. And they're bad because they're kind of dumb. They don't look at the packet contents. And nowadays, everything uses HTTP anyway. So you don't know whether it's an instant message communication using HTTP, or somebody's visiting a web page, or somebody's downloading malware, or it could be even a VPN connection. So everything uses HTTP, and packet filtering firewalls need to allow HTTP through. Therefore, they're not doing a whole lot of work nowadays. They're basically just allowing everything through and blocking, old kind of outdated attacks that might be coming in, but not the more sophisticated stuff like phishing and malware. To go back in time a little bit to the 90s, really, I want to talk about stateless firewalls. They're the predecessor to the stateful firewalls back in the day when enough memory to store all the connections coming in and out would have been kind of expensive. We'd set up stateless firewalls that just provided the most basic filtering capabilities. They, of course, didn't do any sort of network address translation, but back in those days, everybody had a public IP address because NAT didn't really exist, and IP addresses were free and plentiful. The company I worked for, BBN, had several Class A networks and a whole bunch of B and C networks. That might not mean much to you if you're not a networking guy, but we had access to millions and millions of IP addresses, a significant percentage of the overall IP address space on the whole internet. So it wasn't a problem for everybody to get a public IP address, and that also meant that every incoming connection was addressed directly to your computer and didn't necessarily have to go through a firewall. So stateless firewalls were the first of the firewalls that were introduced, and before then we had nothing. So when we first introduced these stateful firewalls, they would always allow web traffic, because of course even back then the web was important. So they would allow anything outgoing that had a destination port number of TCP/80. They would also allow anything incoming that had a source port number of TCP/80, because it might be coming from a web server. And because it's a stateless firewall and it didn't know if you'd already made a request to a web server, it just let every packet that might be from a web server into the internal network. It was so easy to bypass these stateless firewalls because you would just set your TCP source port number to TCP port 80, and it would look like web traffic and get right through the firewall. So that's why I say on the slide that stateless firewalls can't distinguish real responses from fake. So the strength is they were available to 22-year-old Tony right out of college, and everything else is bad. And you won't see stateless firewalls. I just wanted you to know the term, because it might pop up on the exam, or maybe you just want to tell a crazy anecdote like me. Now let's talk about the latest generation of firewalls, which are application layer firewalls. Application layer firewalls work at layer 7 of the OC model. They can look at the contents of the packets. So besides knowing that a particular packet is using TCP port 80, they'll look at the HTTP code in it and say, oh, this is an HTTP GET request. That's allowed. They can say, this is an HTTP PUT request, which is used for uploading files, and I don't want my users to upload files, so I'm going to block that request. They can even say, oh, this guy is downloading malware.exe. I'm not going to allow that, but I would allow some other file that he was trying to download. So they have a lot more insight into the network communications, and therefore they can make much more intelligent decisions. So their strengths are they can filter content, not just protocols, and they can audit app usage. They can actually generate a list of every web page that your users visit. You can see how much time a day users are spending on Facebook or Reddit, and then you could even chase down the individual users if you want to and tell them to knock it off and get back to work. Their weaknesses are that they're more expensive because they do more, and of course because there's more processing, they tend to be slower. But these weaknesses are kind of negligible nowadays. You know, when they first came out, when Microsoft was making these complex application layer firewalls running on Windows, they were really expensive to get the big computer hardware and all the software that you needed, and they really noticeably slowed down your network traffic. Nowadays, it all happens at wire speed and nothing gets slowed down, and you know, a lot of times they're built into more complex software anyway, so you might not have to pay anything extra to get an application layer firewall. Now I'm going to demonstrate both network and host-based firewall configurations just using firewalls that I have around my house. The specifics of this aren't going to be on the certification exam. I just want you to be exposed to how this is done in the real world. So enough theory, let's get our hands a little dirty. This is the Windows Firewall with Advanced Security Console in Windows 8. And here I've shown the inbound rules. These are all rules that are configured by default. So you'll see that there are just dozens, hundreds of different rules that configure which traffic is allowed in and out. Over here on the left, you'll see different sets of rules for inbound rules, which I'm looking at now, and outbound rules. Inbound rules controls traffic that is unsolicited coming into the computer, and outbound rules controls whether traffic is allowed to connect out. Generally, the inbound rules are much more strict. It's kind of common practice to allow any apps that the user might run to connect to the network. That's the outbound rules. On the other hand, for the inbound rules, you tend to drop all traffic that hasn't specifically been allowed through the firewall. So let's take a look at the more strict inbound rules. You can see that for something like what they consider to be the core networking, there's actually dozens of different rules that describe different protocol types. So here we see a couple of different rules for DHCP, which allows the computer to receive an IP address automatically when it connects to the network. IPv6 has its own rules. You can see all these different protocols that nobody knows what they do, but they have their own firewall rules. I'll scroll down a little bit. Network discovery is an interesting protocol. Now on your home network, this allows you to find other computers that you might want to share files with. It allows you to find a printer. It also in the past has had a few vulnerabilities. Network discovery requires your computer to broadcast to the network, I'm here, I have files and printers, and that's great at home when you trust everybody, but you wouldn't want to go to the airport and have your computer be telling everybody, hey, I got a bunch of files over here that they're not protected or anything, if you want to come open them. And so what Windows Firewall does is it configures 3 separate profiles: domain, private, and public. Domain is when you're connected to a corporate network, and private is when you're connected to home. Public is everything that you haven't configured as private or a domain. So the public would be an airport or hotel network. Private would be your home or your small office, and a domain would be your enterprise office. Now you can see that network discovery here is turned on for private networks, but if I expand this a little bit, you'll see it's turned off for public networks. And that makes sense because enterprises have directory services, so they don't need network discovery, so it gets blocked just to improve security. But you do need it at home, so it's allowed in a private network. This is the type of decision that a host-based firewall can make, and it's really intelligent. Scroll down a little bit and we'll check out remote assistance. Remote assistance allows a helper at a remote computer to take over your workstation screen and help you out. Basically, it allows remote troubleshooting, and it's terribly useful. And you might use it in an enterprise. Therefore, it's allowed for domain networks. It's also allowed for private networks like your home because you might use it across your home network. But it's not allowed by default on public networks because it is a security vulnerability. It always prompts for a password, so you should be able to leave it open and not get your computer hacked. But the firewall is all about reducing the attack surface. So even though I don't know of a vulnerability in remote assistance, I'm glad it's turned off by default when I absolutely will never need it. Because if there is a vulnerability that hasn't yet been discovered, I'll still be protected. So it's belt and suspenders security. Remote assistance has its own built-in security, and that's the belt. But the Windows Firewall, blocking all incoming connections, well, that's the suspenders. So I'd have to mess up a couple of things. There'd have to be a vulnerability in remote assistance, and I'd have to turn off Windows Firewall or change this rule to allow incoming traffic through in order to actually get hacked. Now let's close this and we'll take a look at my consumer network firewall. This router has quite a few firewall capabilities built right into it. This is the URL filter. You can see that this page allows you to configure what they call a blacklist or a whitelist. If you configure a blacklist, you provide a list of URLs that nobody is allowed to visit. If you configure a whitelist, you provide a list of URLs that people are allowed to visit, but they can't visit anything else. Usually the blacklist is more practical. But let's say I wanted people not to go to trainsignal.com. I could just put in the URL www.trainsignal.com and then add it to the list. And now nobody on my internal network would be able to access trainsignal.com. But I would never want to do that to my family, right? That's a fantastic website. The access filter here provides traditional port and protocol-based filtering. So you can see that I can configure it to block all access except for the protocols allowed, or to allow everything. I can configure ICMP filters to, say, block ping requests coming in or out. At the bottom are a bunch of default rules that all happen to be disabled because I basically allow all outgoing traffic. But if, say, I wanted to block news traffic, which is a protocol commonly used for file sharing, I could simply enable this rule, and nobody on my internal network could use news. Now this firewall, like most firewalls, is configured to allow all traffic going out by default and no traffic going in. So what I'm configuring to block here is basically outgoing traffic. Now I mentioned that it blocks all incoming traffic by default. Here, if I want to allow incoming traffic, I need to go to the virtual server page. This will allow me to configure port numbers that are forwarded to a host on the internal computer. You can see that I have 2 different rules configured here. One on port 80 for HTTP traffic. This goes to an internal web server that I have running on my home network. this one is enabled. And pretty much every other rule is disabled, which means the only incoming traffic that gets through my firewall is traffic that's on port 80, and that gets sent to the server at this particular IP address. This page allows me to configure a demilitarized zone, which is a separate network segment used for servers that are going to receive incoming connections. It just allows me to break the network into multiple segments and isolate client computers from server computers that receive network requests from the internet. The Upnp Setup page is also firewall related. Upnp is universal plug and play, and it allows client apps running on the internal network to receive incoming connections. This is pretty common. For example, with instant messaging apps, sometimes you'll want to establish a connection directly between two clients. Now, they can't connect directly unless one of them is allowed to receive incoming connections. So what will happen is one of the instant messaging apps will talk to the firewall and will say, hey, I'd like to receive incoming connections on this port. When you get the next request, will you please send it through to me? That's what Upnp is. And if you've enabled it, as I have here, that'll all work seamlessly, and any computer on your network can receive incoming connections at that computer's request. The session limit page on the firewall rules here allows me to configure some details about how it handles different aspects of connections. Potentially this could be used to limit your risk to denial of service attacks by blocking the number of requests that can come from a single host. Still wouldn't protect you from distributed denial of service attacks, however, because they involve many more computers. Now, just because it appears on the SSCP objectives, I want to talk about proxy servers. A proxy server, as you can see from this diagram, looks an awful lot like a firewall server. It sits between the clients and the internet. So what's the difference between a proxy server and a firewall? Well, realistically, nowadays there's not too much. We used to call layer 7 firewalls proxy servers. If it could inspect the packets at an application layer, we considered it a proxy server rather than a firewall. That's the big difference. Nowadays, with modern technology, firewalls and proxy servers have merged, and I almost never hear the term proxy server anymore. We just talk about firewalls. So as I mentioned, proxy servers exist at OC layer 7, the application layer, the top layer. They basically terminate the incoming connection. So a client will connect directly to the proxy server rather than the final destination server. The proxy server then initiates a new outgoing connection. So if we're using a web proxy server and I want to connect to trainsignal.com, my client computer connects to my proxy server. And it says, hey, would you mind opening a request to trainsignal.com for me? The proxy server then becomes the web client, and it opens a request to trainsignal.com, passes the request on from my client computer, receives the response, and then starts acting like a server. It uses its server connection to my client computer to feed the response back to me. Because proxy servers work at layer 7, they have to be application specific. Most firewall features happen at layers 3 or 4, so they're looking at the IP packets and the TCP or UDP headers, but they don't care whether it's an instant messenger app or a web app because they're just treating most of the packet like data. Now, if you were to throw them something that wasn't IP, if suddenly you had NetBUI packets or something different, they'd be at a total loss. That would require some device that could operate at layer 2. Proxy servers, being at layer 7, have to have intelligence in that. Proxy servers, being layer 7, have to have intelligence at that level. So you could use them to proxy a web server connection, but that doesn't mean that you could use it to proxy a FTP connection or a file server connection or an instant messenger connection. However, because they work at layer 7, they can examine application contents and look at URLs and the different files that you're retrieving and even the contents of a web page that you're looking at. Usually proxy servers require client configuration, whereas firewalls work transparently and kind of grab your traffic off the wire. Most proxy servers require you to actually go in and configure the client computer or the web browser to talk to the proxy server instead of the final destination server. There is a protocol that will allow web browsers to be automatically configured to talk to a proxy server because, during the late 90s when web traffic was still getting more and more popular, proxy servers were popular for accessing all sorts of internet traffic. They've now been completely replaced by firewalls, so I don't expect that you'll ever have to configure a proxy server in your real-world work. but please do be aware of what the term proxy server means and what it meant historically. To reinforce the connection differences between proxy servers and firewalls, here are a couple of artfully drawn diagrams. You can see, as I described, the client establishes a connection to the proxy server and then provides instructions for the proxy server to connect to some server somewhere else, probably on the internet. With firewalls, however, the firewall might be processing the packets and even changing the contents of the packets, but the client doesn't require any special configuration. In fact, the client always thinks it's connecting directly to the server. Likewise, the server thinks it's connecting directly to the client. Neither one of them are aware of the firewall in here. Here, the server is not aware of the proxy server, but the client is aware of the proxy server. This is Tony Northrup for Train Signal, and thanks so much for watching this video lesson.